Hey, what's going on, everybody? Hope you guys are doing fantastic. Welcome to the Master Automotive Training Advanced Engine Performance, or L1. In this class, we're going to be covering everything you guys need to know to not only be an amazing diagnostician, drivability tech, and emission repair technician here in California, but we're also going to be teaching you guys everything you guys need to know to pass the ASE. Now, if you guys are planning on taking the ASE L1, keep in mind that in order for you to qualify for the L1, you need to have taken the ASE A8 and ASE A6 and passed both of them. Once you have those two exams, then ASE will allow you to take the L1. Once you have the L1, you are a very valuable diagnostician. So I strongly urge you guys to make sure that you guys take the time to pass the A8, the L1, the A8, A6, and then make sure you guys pass the L1. Now, if you guys have any questions throughout any type of this class, make sure that you guys come up here to the top right-hand corner to the chat function, enter it in the chat, and then that'll come over to us here at the school. When you guys send any messages to us, we will definitely do our best to answer those as quick as possible, because we completely understand that if you guys have a question, that means somebody else might have the same one. So we're going to get you guys the answer as quick as possible. So if you guys are ready, let's get going. What we're going to be covering throughout this entire class is going to be general powertrain diagnosis, computerized powertrain diag. That's a 2-day lecture. Then we have an ignition system diag. We're going to talk about fuel system and air induction. We're also going to talk about emission control devices and diagnosing. And we're going to finish it off with emission failure diag, which would be, if you're not in the state of California or you're not in an emission state, then that's going to be something that, unfortunately, you're not going to have much control over. But I do recommend that if you guys learn the 5-gas, purchase a used 5-gas analyzer. If you guys are like us here in California that we're required to actually have a 5-gas if you're a smog check station, then we use that more than just for emission inspection. We actually use it for diagnosing purposes also. And that's what we're going to be covering with you guys in that section. Anytime we're going to start a diag, I always recommend to start with an interview of the actual customer. Now, I get it. Some of you guys might have a service advisor that is your liaison between the customer and you. However, your customer needs to be properly interviewed. Now, if you guys are here in the class, you're going to get access to this PDF worksheet that we've put together. We've also had some input from a couple of great automotive instructors, Jim Morton for one, and we used some of his format, and then we've incorporated some stuff of ours, and this is the worksheet that we came out with. So when a vehicle gets dropped off to us for a diagnosis or an evaluation, we make sure that this worksheet gets filled out. The more information we have pertaining to when the problem occurs, the easier it's going to be for us to properly diagnose it. So any diagnostic and or evaluation begins with a thorough customer interview. The everyday driver needs to be the one interviewed before commencing any diagnostics. So if it's grandma's car, but grandson brings it, it's not a good idea to use grandson's explanation. If grandma gave him 10 minutes worth of information of how the problem occurs, grandson's just going to say it makes a noise. So we want to make sure that we interview grandma so this way she can give us every single detail of how we can duplicate that problem. And then this way it's going to give us a better chance to properly diagnose it and repair it on the first try. This interview is going to lead you into the correct path of diagnostic approach. That is 100% true. The more information you have on that diag, the easier it's going to be to diagnose it. Now, I started implementing this after I was at a shop once, and I got a car that came in for noise. Well, when I went out and tested the car, I spotted a noise, but once we repaired it, it was a different noise that the customer was actually concerned about. And from that point forward is when I started developing a diagnostic sheet. And also, one thing that we do is we go on a road test, because if I go on a road test with the customer, it gives me a chance to be able to see, listen, and be able to duplicate the concern that they're having with their car much easier than if I was doing it on my own. So I always try to keep that in mind if you guys are out in the shop. Make sure you guys do a proper interview, and then at the same time, try to go out on a road test with your customer to make sure that you guys are actually focusing on the right concern. Another key thing is this a concern or a complaint? Now, if it's a concern, that's going to be something that interests you because it's important or affects you. That is the definition of concern. A check engine light is on and it has a rough idle. This is a concern for this particular car. A complaint is an objection or something that is unfair, unacceptable, or otherwise not up to normal standard. Customer complains about noise from their new mud terrain tires. So we need to be able to differentiate the two. Now, if I have a customer concern, this means that it's an issue that I'm going to have to pull tooling out. If it's a complaint, usually it means you're going to have to look in the owner's manual or find some source of information that's going to help them understand that that is something new with their car. Now, I don't know if you guys have had a customer before that's been a good customer for years. They finally decide to get rid of their clunker. The new car they pick up has different buttons and features that the old one didn't. So they bring it into you saying, hey, you know what? My car is doing this and that. And then when you go out and check it, it's like, oh, yeah, well, your car used to have an, 6 CD changer. Now you have Bluetooth. That's why you can't use that particular adapter on your car. So that would be a complaint, because at that point is you have to explain to the customer that it's a new technology advances, and that's why you're having that different issue that they were used to not having prior with their older clunker. So here's a good example of a concern. Customer concern. Vehicle lacks power going up a steep hill. It has a check engine light on with a 171 and a 174. Both fuel trims are showing plus 35% on long-term and short-term fuel trim. So this means we have a lot of fuel adaptive on both banks. This is a concern since you have a mill and a drivability issue, and it can be felt by the driver. This would be labeled as a concern. So if a vehicle comes in and it meets this criteria, you're going to call that a concern. So that would be your customer's concern. Now, a customer complaint, and this is one that I actually got to work on. A Ford F-250 came in, I think it was like a 2007 or 8, and the customer's complaint was they were not able to control the radio below a specific speed. The previous shop that actually worked on it was trying to replace the radio, but the customer said, no, that doesn't make any sense, right? So they brought it to us for a second opinion. This to me was actually relatively new and weird because I had never run into this type of situation. So I did what every good technician would do. I pulled out the owner's manual. So I dug in the glove box, found the owner's manual, and then I started reading. What I found was this Ford product had a vehicle compensated volume, or some vehicles call it a speed sensitive volume control, or SSV, and it had been turned off. So all I did was go through the menu functions on the radio and I turned it off, and voila, the problem was gone. So what I ended up doing is I documented all of that, and then when the customer came, I went and showed the customer, like, look, this is what happened. If this happens again, somebody accidentally turned it on, go ahead and go through your menu section and then turn this back off. Now, most of you guys were probably saying, well, why didn't you just sell them a radio? I could have, but if I would have sold them a radio and then inadvertently somebody did this again and the vehicle is still under warranty, when they come back to the shop, what are they going to expect? Another radio. And if you pull the radio out and you try to get the manufacturer to warranty it, they're going to say there's nothing wrong with it. And then what are you going to do then? Let them know that, so I messed up the first time and sold you this super expensive head unit, when in fact, all you really need to do was do a button sequence and turn it off. This is why it's important for us to be able to differentiate whether it's a complaint or a concern, and then how we're going to be able to approach it to be able to repair it. Anytime we're going to start a diag, always make sure you guys start with the visual inspection. I can't stress enough how many times we've gotten cars into the shop where another shop was recommending a bunch of repairs, when actually all the car needed was just some visual repairs, some stuff that we saw visually, and it didn't need any in-depth or any crazy type of diag. So when you're doing a visual inspection, make sure that you guys do stuff like check your belts. If the timing belt's accessible or has an access hole, kind of take a look at it. Serpentine belts, take a look at that. Radiator hoses, vacuum hoses, crankshaft pulley, alternator pulley, Sensors, make sure that they don't look like they're oil contaminated or broken, zip tied together, taped together. All covers are there, and if you possibly can, check the functionality of certain components. You can most of the time do that with a scan tool on the bidirectional side. Now, something that's also very important as automotive technicians, when a vehicle comes into the shop, not only are you guys performing a diag, but you're also doing a visual inspection. This visual inspection helps you and the shop be able to recommend other services that might be needed by that vehicle. So that way the customer is aware of it, and then they can get that done at a later time or at that time that the vehicle is in. Particularly when it comes to hoses, hoses actually deteriorate. And if you don't fix them or replace them prior to their deterioration, then that's when you can get a blown radiator hose that causes the vehicle to overheat and then turns out to be an entire engine overhaul. So make sure that you guys are also working with your shop foreman or your shop owner to create some sort of recommended intervals for these types of components. So this way you guys can recommend these to your customer when the vehicles are coming in for service. Part of your visual inspection, make sure you're looking for modified components. Did they add anything aftermarket that wasn't there that came from the factory? Supercharger, turbocharger, did they add some sort of lighting kit? Anything of that sort, pay attention to it. Has this vehicle been welded or modified? Right? That's a big one. If the vehicle was in an accident and they re-welded, let's call it the front bulkhead, that can cause a ground delivery problem. So that could lead to other faults. Are there any altered brackets or mounting points? Was anything moved, repositioned? Are there any non-standard materials used? Did they actually paint over a ground? Right? So we want to make sure that you guys can do any type of those visual inspections. So this way you can see right off the bat, do I spot anything here that might be suspicious that might be causing this issue? Tampered components would be anything that's disconnected or bypassed, altered wiring harnesses, damaged or tampered seals, signs of any forced entry or attempted repairs, functional impact, like was the vehicle hit in any way, shape, or form? This one's important. Like when you come to some of the Euros, they keep the modules or used to keep the modules in a box, plastic box. And if the front windshield was replaced and not sealed properly, then you can get a lot of water filling up in that plastic box. So then what's sitting in that box? About 4 to 6 modules. And then once they get filled with water, what's going to happen is going to fry all of them. So this is why it's important that you guys do a visual inspection so you can determine if any of that's at play before you actually recommend any type of repair. When it comes time to diagnose a car, you always want to start with the 4 C's. What are your 4 C's? Concern, cause, correction, and the one that most technicians do not do, confirm. So let's go ahead and jump into them real quick so we can take a look see here. So a concern. Vehicle comes in with the mill light on. You pull the DTCs and you find a PO300 and a 302. You feel a rough idle and it started about a week ago. So now you have an idea of the concern that your customer is actually worried about. Now your job is to come up with a game plan on how you're going to approach this. Typically, one thing we do when it comes to any type of diag, after we find the concern, we're going to do some sort of general test. Especially being that if this vehicle has a misfire, I would have started with a relative compression test. That would be using an oscilloscope on the battery, either with an amp probe or directly connected directly to the battery to verify if all cylinders are contributing the right amount of compression. This way, I can rule out a mechanical problem right off the bat and then start moving into ignition or fuel. So we run an RC test to rule out a mechanical fault, and that one passed. So then we use a scope to monitor current and voltage to the fuel injectors. So notice here on the bottom in red would be the voltage, and on the top we have the current. So this vehicle is a 4-cylinder, so the firing order would be 1, 3, 4, and 2. Notice how I have current for 1, current for 4, and current for 2. I don't have any current ramp for cylinder number 3. So at that point, we would say that this vehicle has a misfire because of an injector that's not actually turning on. Now, if you guys see here, is that the root cause or an effect of the problem? And the reason I say that is remember some newer vehicles, the engine computer will turn the injector off if it detects a misfire. So in these types of cases, what you want to do is you want to save your freeze frame, then clear the codes and see if that injector waveform comes back. If it doesn't, you just confirmed that it is a bad injector. Now your job is to figure out, is this a shorted open injector? Is it a power feed problem or is it a control side problem? Which is relatively easy to do. From there, the correction would be to replace the spark plug and replace the fuel injector. Why both? Well, the reason why you want to do both is if you had a problem with the fuel injector, that could have caused damage to the spark plug itself. If the spark plug was overheating or anything of that sort, it's best to go ahead and replace those as a pair. So this way, if the vehicle, once the vehicle takes off, you're not running the risk of it coming back for something similar, and the customer is going to say, you guys didn't fix it properly, the problem's back. Then lastly, you want to confirm your repair. This is the step that most technicians skip. What they end up doing is they do the repair, and then their test drive is so rigorous, it's just pulling the car out of the bay and then parking it in the stall. When you're doing your confirm, well, since we ran an RC test, rerun it. Rerun your RC test, rule out a mechanical problem. Then afterwards, use your scope to monitor current and voltage. Now, if you guys could see, we have voltage on the bottom, and then now I have 4 current events at the top. So we fixed the problem. Now I can confidently return this vehicle back to the customer, knowing that the problem or the concern for which the vehicle was in for was properly repaired, and I'm not going to have a comeback later where the customer is going to say, you guys didn't fix it, the car's still doing the same thing. So one of the things you guys want to get comfortable with before you start working on the car is service information. Anytime you guys are working on a particular car, always make sure that you guys get all your ducks in a row. Do your research, pull service information, pull wiring diagrams, set up a plan before you start testing the car. One of the things we do is once we pull a car in, we're going to pull the codes. Once we have all the codes set, then afterwards, we're going to start working on our plan. And the reason we want to do that is we don't want to be wasting time going back and forth or switching from one test to another without actually knowing if that's a good idea or a good process. So service information is going to be super important. Like we said, we had a misfire, so we can look up misfire counters here. And then this information is going to let you know how the system works. So based off of the information here, the system's telling us, or the manufacturer's telling us, that the PCM uses a crankshaft sensor for misfire detection and to control spark and fuel. As the crankshaft rotates, the reluctor wheel teeth interrupt the magnetic field produced by a magnet within the sensor, producing a signal in which the PCM reads. That's positive information. Now, this is one thing that a lot of technicians suffer on because they don't go and read the service info. Now, one thing that I'm a big believer in is if you know how it works, you're going to be able to fix it. So this is why we always want to turn to service information first, so we get a good understanding of how the system works. So here's the whole diagnostic procedure for a misfire on a GM product. Now, one thing that I can tell you guys is at the beginning, you might be following each individual step. Now, one of the things that happens with all these steps is a lot of times they're redundant, or the steps are going to say replace with a known good component. Unfortunately, we don't have that luxury. Your best option is to kind of read over the whole diagnostic procedure and then determine what are some tests you can run and what equipment would you use to run those tests. Run them and then verify with your diagnostic procedure which way you're going to be headed with the remaining part of that diag. Always too, make sure that you guys are looking at your diagnostic aids. So most service information are going to give you a little diag aid that we call it. So this one, if more than one cylinder showed a history code for misfire, look for something in common between the cylinders, such as a shared coil. Also check for vacuum leaks that affect this affected cylinder. If fault cannot be duplicated, secondary ignition system with water, mist it with water, and then operate vehicle under conditions to set DTC. So these diagnostic aids are very important. They're telling you this because that means that several technicians, or a lot of technicians around the country, have ran into similar issues, and this is what their tech help for the manufacturers is recommending you to do. So again, this is why we look at all this information before we start testing the car to make sure that we have every angle covered when we begin to run our tests. The other one that I see most technicians not do is a technical service bulletin, or TSBs. What ends up happening is the technicians get so into a hurry and a frenzy to try to get it in and out that they don't bother to look at TSBs until the very end. What a technical service bulletin is, it's letting you know of common issues that manufacturers have seen with particular cars and particular faults. So for this one, information on rough idle, crank no start, extended crank, or misfire due to excessive carbon on the top of the valves or sticking valves. And then it gives you a list of all the misfire codes you might be attributing with this fault. Now, why would it be a good idea to do this? What happens if this vehicle was in your service bay and it has a misfire and you've tested everything and everything tests out fine? Well, if you didn't bother to take a look at the TSBs, what are you going to probably end up selling them? Maybe spark plugs and coils, right? So this is why we want to make sure we look at the TSBs before, so we're 100% sure that what if this TSB might be related to this particular fault on this car. And as I was saying earlier, you always want to know, how does this system work? If you don't know how the system works, you can't fix it. So computerized engine controls for gasoline input devices and cranking signal. For the crankshaft, cranking signal is a 12-volt monitored by the PCM. Signal is present when the ignition switch is in the start position, and the PCM uses the signal to determine the need for starting enrichment. PCM also cancels diagnostic until the engine is running and 12-volt signal is no longer present. So the PCM is going to be monitoring that signal to get the vehicle to start. That's super important. What if you get that car that comes in as a crank no start, but you weren't aware that the crank signal was the one that was looking by the PCM to know it needs to enrich it for startup? Okay, so this is why we always have to go to service information to know, is this how this system works, or how does this system work for me to properly diagnose it? And anytime you guys are going to be doing a diagnostic, either for a mill light, a drivability concern, an emission failure, always remember these three funnels. It's an air fuel, mechanical, or an ignition problem. If it's air fuel, that's going to be fuel trim, volumetric efficiency, or calculated load. If it's mechanical, that could probably be valves, rings, maybe crank, maybe timing. If it's ignition, is it primary, secondary, or the coil? So my job as a technician is to quickly get into one of these three funnels. Now, here's a good example. If a car comes in and has a drivability concern, lack of power, what happens if I add propane? Does the power come back? If the power does come back after I add propane, what could that be? That could be a fuel delivery problem. So now I'm going to fall into the air fuel funnel and I'm going to stay there. Now I'm going to start testing everything in relation to air fuel before I go into mechanical or ignition. This is the beautiful thing about understanding the funnels, right? We always want to do a general test first and then start going into the other tests to then determine exactly what is causing your customer's concern. So this is what I was just talking about a few seconds ago: general testing versus pinpoint testing. Now, if a car comes in and you want to test for a misfire, relative compression test is a general test. This is going to let you know, do I need to go pinpoint compression or a leak down? If it's a breathing problem, do a volumetric efficiency test. Then your pinpoint test would be fuel pressure, fuel volume, exhaust restriction, or timing. Add propane. If that helps, then it's a fuel pressure or fuel volume problem. Wide open throttle, open loop acceleration. And if it goes into open loop and the problem goes away, then that means that it's a fuel pressure or fuel volume situation. So just for a quick reference, the 4 strokes of a 4-stroke engine are intake, compression, power, and exhaust. So here in the shop, we have a thing called the rule of 3. And for some reason, it's always 3. A car will come in and say, hey, we already replaced three injectors on this particular cylinder and it doesn't go away. We replaced 3 coils. We replaced 3 modules. I don't know why it's always 3. So we came up with the rule of three. Please don't fall into this trap. This is for the guys that are not trained and don't. Here at the shop, we have a funny, we call it the rule of three. We have a rule of three that we make a big joke out of. But it's sad because it is a joke. However, this is the most common thing that shops and techs do out in the field. So typically, we'll get a car that comes in, and no matter what the problem might be, they've replaced three or more of that same component. We've had cars that come in, and there's a box of goodies, we call it. It's all the parts that have been thrown at it or replaced in the attempt of fixing the actual car. Um, we've seen cars with box with three modules, three throttle position sensors, three throttle bodies, and stuff like that. And that's why we came up with what we call the rule of three. But with you guys being really good techs and attending training, you guys will not be part of the rule of three. So just if you guys hear it, it's a rolling joke that we have here in the shop, and that's what it means. So one of the things that we can always do as a tech when the vehicle comes in would be to do a compression check. What the compression check is doing is it's giving us and testing the engine's ability to seal. And it's always a good idea to make sure that you do this with the engine hot. This way we can make sure that everything has expanded and seated properly. And then now we can run the test. What you're going to do is you're going to disable fuel. You're going to remove the spark plugs and disable spark. The reason why you want to disable fuel is you don't want to wash the cylinders. And then you want to disable spark because you don't want to burn out the ignition coils. You want to introduce your compression tester into each individual cylinder, hold the throttle pedal wide open, and then crank the engine several times, usually about 5 to 10 revolutions, until you get a steady or a no more bouncing or increasing compression needle. Make sure that your compression hose that goes into the cylinder has a Schrader valve in it. Do not remove it. You only remove that if you're using the testing hose for a pressure transducer. Then you want to repeat on all cylinders and then document it. So we're going to provide you guys with a worksheet where you can actually write all this stuff down, because this is pertinent to your diagnostic and also your technician notes when you are providing those to the customer or your service advisor. After you do a compression check, the next step should be a running compression. A running compression test is going to test the engine's ability for volumetric efficiency. How well can that engine take in air? That's what we're measuring with a running compression test. Again, you want to make sure that the engine is warm. You're only going to remove the spark plug for the cylinder that you're going to be testing, and you want to disable fuel for that particular cylinder. Also, make sure you ground out the coil or the spark plug wire for that cylinder as well. Start the car up, and then what you want to do is burp it right away. And then once the compression reading comes up, you should be at about 50% of that of static. So perfect example, if you have 160, you should be at 80 running, right? So we always want to make sure that not only do we do the static test, but we need to follow that up with the running test. And this is where I see a lot of technicians drop the ball. They completely miss out on doing the running compression check. All they do is the static and then move on. We need to make sure that we also do the running compression check. So a wet compression check. What were to happen if we run down and we do the test and then we notice that one cylinder is less than the other? Well, one of the things we could do is we can add a couple of drops of of oil inside the cylinder. What we're doing here is by adding the small amount of oil, usually about a teaspoon or so. If the compression comes back up within about 10 to 20 psi or percent, this is indicative of worn piston rings. So if you add the oil in there and then the compression comes back up, you're now 100% sure that this engine is going to need to be rebuilt. Okay. After you run that test, right, you can also follow it up with a snap compression test. Here, what we're doing is we're testing the engine's ability to breathe under high load. And by doing so, what we're going to do is we're going to start the car up, and then we're going to do a snap throttle, wide open throttle acceleration. Your compression reading should be at least 80% of that of static. And if it's lower than 80%, you want to look on the intake side for problems. And if it's higher than 80%, you want to look for problems on the exhaust side. Again, this is a test that most technicians do not run, and you should be, because this is how you're going to verify if the engine can breathe properly under high load. Now, if all your compression checks come out bad, then your next step is to do a pinpoint test, right? So far you've done a compression check and that's verified or confirmed for you that you have an engine mechanical problem. Now, what you want to do is pinpoint it. Where is it at, right? Where is the problem at? So that's when we start doing a pinpoint test of a cylinder leak down. With a leak down test, you can tell if the loss of compression is due to things like worn piston rings, a burnt or stuck valve, or a leaking cylinder head gasket. What you want to do is you want to go ahead and raise the cylinder to top dead center compression, remove the spark plug, put your leak down tester hose in there, and then put your tester adapter. Once you connect the adapter to the cylinder, you should have up to about 20% loss. That's absolutely normal, even on a brand new engine. And the reason why is we have piston and ring gaps. So we're always going to lose a small amount of compression through those end gaps, and there's not anything you can do about it. Now, if for some reason you have more than 20% loss, then at this point, you need to start pinpointing where it's at. If you hear air coming from the throttle body, that usually means that you have an intake valve that's not sealing properly. If you have bubbles in the coolant, it could either be a blown head gasket or a cracked block. If you hear air in the exhaust, that would be an exhaust valve. And if you hear air in the crankcase or dipstick, then that would be a leaking piston rings. And that's why you have that loss of compression. One thing that I do when we're doing the exhaust one is we'll put a glove, our normal latex or nitro gloves in the exhaust. And then if that glove begins to fill up, then we know that it's an exhaust valve. We also do that with the crankcase or the intake, and it helps us really easily identify if that's where we're hearing the actual air coming from. We can also do a basic test like a vacuum test. So a vacuum test is a great way to determine the engine's overall breathing capability, but does not provide results for each individual cylinder. So remember, if you're connecting a vacuum gauge, you're connecting to the intake manifold. The intake manifold is going to be a central junction for all cylinders. If I have 4 cylinders, all 4 of them are connected to that intake manifold. So each cylinder, as it creates vacuum, that's going to be distributed throughout the manifold. So one of the best places to check for vacuum would be at the purge valve hose. And the reason why is a purge valve hose is typically going to be in a centralized location. And the reason we do that is because what does a purge valve do? It sends hydrocarbons into the intake. So we want to make sure that those hydrocarbons are going to be evenly distributed between all cylinders. So that would be one of the best places to actually connect. Then once you connect your vacuum gauge, go ahead and start the engine up. A good engine at idle should be 18 to 22 inches or 17 to 21 inches, depending on who trained you and where they read that information from. Also, for every 1,000 feet of elevation gain, you lose 1 inch of vacuum. So that's also important to take into consideration. Like, for example, here where we're at about 1,500 feet elevation. So we'll round up to 2. So we're going to lose 2 inches. So instead of 18 to 22, we're going to be 16 to 20. Okay. And that's important to know whenever you guys are doing a vacuum check. If I'm looking at a vacuum gauge and I notice that my vacuum gauge is dropping about 1 inch of vacuum and it's happening consistently, right? But not back to back, but it would seem as it's happening like on every other stroke or something like that. That's an indication to you that you have a valve seating problem, and it's usually only going to be about 1 inch. Okay, so we need to look at that. And again, this is something that we actually diagnosed on I think it was a 2019 Jeep that came in from another shop that misdiagnosed it. They called it spark plugs. And when the Jeep came in, all we did was connect the vacuum gauge, and that's what we were seeing is a drop about 1 inch, and it was happening maybe about every 1 to 2 seconds. And then we narrowed it down to a cylinder. We ran in-cylinder testing, and that's how we figured out that it was a bad valve. So the vacuum gauge was the one that led us to run these other multiple tests to then verify if that was really the fault. Now, if you have a needle that's vibrating, so you're going to see it bouncing back and forth, that usually indicates that you have worn valve guides. And at that point, then you're going to condemn it and do a valve job. The other one would be if you have broken valve spring. So what you want to do is you want to increase the engine RPM at about 2,000. And about 2,000 RPM, if you start seeing your needle jump in about 12 to 24 inches, just back and forth, that usually means you have a broken valve spring. You can also see this on secondary ignition. So when we get to ignition analysis, we're also going to be talking about that. How does your engine computer know that you have a misfire? Well, one of the ways it does that is by looking at the crankshaft position sensor. Would you guys agree that the crankshaft position sensor has a reluctor wheel with a fixed amount of teeth, and and these teeth are a predetermined size? So you should have said yes. Now, because of that, would you agree that there's no way that any one of those teeth could get larger or smaller? And they can't, because they're already a predetermined size. Now, if for some reason the PCM detects a longer tooth, that's how the PCM knows that there was a crankshaft slowdown. And if the crankshaft slowed down, what is that indicative to the PCM? There was a misfire. Something caused that cylinder not to fire properly, and that's why it elongated. So that's how the PCM is able to know that there was actually a misfire. One of the things we always want to do when a vehicle comes in is always start off with a digital compression check, which is known as a relative compression test. Now, the reason why we do this is a very simple test, and it helps us quickly identify if we have a mechanical problem. There's nothing worse than getting started on a diagnostic and where you think it might be spark plugs, you put plugs on it and coils, you start the car up and it's still misfiring. Then once you go and do a actual compression check, you're like, damn, this car has low compression. Well, if you would have done a relative compression test from the get-go, you would have known that, and instead of ordering the plugs and coils, you would have gone straight to a mechanical compression check. So this is why it's a good idea to make sure that we start with an RC test, or a digital engine compression check. And this is what, oh, my video didn't play. So when we're cranking, the starter is going to pop out, and then it's going to begin to rotate the actual flywheel. So each one of these humps that you see here is going to be, these peaks is the starter using more amperage to overcome compression. If we see a low or missing hump that keeps repeating, that's how we're going to know that we're low on compression. So if you ran this RC test and this is your waveform that you got, what are you going to do next? Definitely going with a compression check is going to be your best bet. Why do we say that? Is notice here we're using the sync up here for ignition, and this is 1, 2, 3, and 4 cylinders. So we have 1, 3, 4, and 2. So if you guys agree that cylinder 4 has no compression, at this point for me, I'm going to do not a relative compression, but an actual compression check on that cylinder. There was no current draw here, so the starter didn't even need to work to actually overcome any compression. So we have a loss of mechanical compression there that we would need to check out. Now, what if for some reason you think it might be a fuel injector that's causing your misfire? Here's the hardest test you can do. Walk around to the back of the exhaust and smell it. If you have fuel that's being injected into the engine, you're going to have the rotten egg smell, the sulfur smell. And if you have that smell, you automatically know that you have fuel. Now, if you have an engine that's misfiring and you go to the back of the tailpipe and you don't get that sulfur smell, you don't have fuel. So your misfire is going to be fuel related. Okay, so this is a good and easy test for you guys to determine, is this a fuel delivery misfire? Now, there's another thing you can also do, and you can use a 5-gas analyzer. Now, I understand some of you guys don't have access to one, or you're not in an emission state. And if you are and you have a 5-gas analyzer, put the probe in the tailpipe and then look at your hydrocarbons. If you have a misfire, your hydrocarbons should be relatively high, over 100 ppm. If it's not, then that means your misfire, again, is fuel related. There's no fuel being injected into that engine. Pretty easy way. Another thing we can do is we could do a quick check on the ignition system. Here what we did is we pulled the fuse out for the ignition coils, because typically the ignition coil fuse feeds all coils. We put a jumpered fuse, and then we put our amp probe around that wire. As you guys could tell, we have one injector, two injector, no injector, and another injector, and then it repeats itself. So these 4 would be the 4 cylinders on that engine. Because this third one here had no current ramp, that means that that injector didn't saturate. That injector does not work. So that is why we're having an, not injector, ignition coil. This ignition coil is shorted. How do we know that? Because it's a vertical rise and then it just cuts off and drops off. It didn't create a ramp like we did on these. So here we could say that this ignition coil is shorted and needs to be replaced. Also, too, we can definitely use our paddle probe and then check for secondary ignition. Now, secondary ignition, we're going to learn more about this in the ignition class, but always make sure that you guys measure your burn time, which is from here to here. That should be 1.0 to 1.5 milliseconds, right? And then your KV, which is this one here, needs to increase with pressure. And then if you notice this line is nice and smooth, like picture perfect, that normally means that that spark didn't enter the combustion chamber because it wasn't affected. It wasn't affected by any type of change. So here, we're also going to be learning about 5-gas analysis later in the class. But if I have 13.1 CO2, 1.5 O2, 125 hydrocarbons, 0.01 CO, and 12 NOx, is this a mechanical or an ignition-related misfire? Let's analyze this real quick. CO2 is about 13. It's within an acceptable range. I have 1.5% oxygen, so I have a little bit too much oxygen left. Hydrocarbons is at 125. It's not too excessive, but it is high. CO is 0.01, and then NOx is at 12. So this is telling me I have extra oxygen that wasn't consumed, and it was pressurized, it was compressed, but it didn't fire. It wasn't consumed. Followed with 125 hydrocarbons and 1.5 CO2, and acceptable CO2. I would say this vehicle has an ignition-related misfire. Now looking at this one, let's look at this one. This one really changed. I got 10.3 CO2, 3.2 O2, 365 hydrocarbons, 0.21 CO, and 12 NOx. Again, my CO2 is really low now, and it's below the acceptable limit. So this being an efficiency indicator, this is telling us that our engine efficiency isn't that good. O2 is 3.2%, and we have a lot of oxygen left over. And I have 365 hydrocarbons left over, and I got 12 NOx. So this to me would indicate we have a mechanical misfire. And we can see that simply by looking at our 5-gas analysis. So we got to be able to use that information, guys, to benefit us whenever we're doing our diags. Here we got another one, which is 13.2, 3.2, 0.6, 0.01, and 210. What do you guys think is wrong with this one? Now, if you said ignition misfire, you're 100% correct. And we can say that because our CO2 is within acceptable limits, our O2 is high, and what's up with our HCs? Nothing too bad. And then we have our So if you guys said this is a fuel-related misfire, you're 100% correct. How do we know there's a fuel-related misfire? CO2 is low, but still within acceptable limits. We have a lot of oxygen left over. Hydrocarbons is actually low, and then NOx is high. So this means that we were able to compress a lot of air, but we didn't consume it. So this would be a fuel-related misfire. We can also use a 5-gas analyzer in manual mode to check to see if we have a blown head gasket. If we remove the radiator coolant cap and we notice that we are reading CO2, the only way we can get CO2 in the coolant is if we have a blown head gasket, because CO2 is a byproduct of internal combustion, right? And if we also have white smoke at cold start and under heavy acceleration, this also indicates a blown head gasket. And if for some reason you would have low compression on 2 companion cylinders side by side, that usually indicates a blown head gasket between the two. Now, if you're seeing white smoke, that typically means that you're burning coolant. Okay, you would need to do a block test or a CO2 test to verify if it is what you think it might be. And if you see black smoke, that typically indicates incomplete fuel combustion. That means that you're burning too much fuel, or you're consuming too much fuel, but you're not actually burning it all, and that's why you're getting that black smoke coming out the tailpipe. And if you have blue smoke coming out the tailpipe, that usually means that you're consuming oil. Your engine is burning up oil and it's being consumed, and that's why you're getting that blue smoke coming out the tailpipe. Awesome. And with that, guys, our first day comes to an end. Now, the lap sheets that are going to be included here, make sure you guys take those with you to the shop. If you guys brought any of your tools, bring them with you. Bring your safety glasses, and then we're going to go ahead and get started with our labs. Again, if you guys have any questions, make sure you guys hit it in the chat function up here at the top, and then we'll go ahead and get those answers over to you guys. Once again, guys, you guys are freaking awesome. I really appreciate you guys being on here. Thank you guys so much, and we'll see you tomorrow for Computerized Diagnostics. See you guys.